To Tech Quest X, where we make tech clear and show what it means for your role. Do you think scaling AI is just about adding more GPU units? We're in an AI revolution. Models are growing exponentially, creating incredible possibilities, from advanced language processing, generating human-like text and understanding complex queries, to groundbreaking scientific discoveries, accelerating research in medicine and materials science. This AI dream, however, comes with a massive, often unseen cost. This isn't just a budget concern for finance teams. It directly impacts your project timelines and operational efficiency. The true bottleneck of AI isn't processing power, it's inefficient data movement and orchestration. Chasing pure GPU speed without optimizing orchestration is just expensive guessing. We've seen the AI dream take flight, but a hidden crisis now challenges its very foundation. AI models, they're expanding exponentially, demanding astronomical computing power. Our existing data centers frankly weren't designed for this relentless demand. Energy consumption is skyrocketing, adding immense pressure to budgets. This isn't just a developer concern. Ops teams manage the physical power grid, and innovation itself is bottlenecked. The problem isn't the absence of solutions, it's a fundamental misunderstanding of efficiency. Simply throwing more hardware at it is no longer a viable or sustainable strategy. We need a radical shift, rethinking how AI compute resources are orchestrated, because the current path wastes billions, threatening to stall AI's true potential. The previous bottlenecks, they point to a deeper, often overlooked issue. Many assume simply bigger, faster GPU systems are the answer, but raw compute power isn't the actual problem anymore. It's the chaotic, inefficient data movement between components that hurts. This isn't just a developer concern. Operations teams feel the acute latency. Such inefficiency leads directly to massive wasted energy, leaving vast AI potential unfulfilled and neglected. Simply adding more GPU systems only scales the problem, not the solution. But what if the solution isn't just more raw power, but smarter orchestration? Here arrives NVIDIA's Vera Rubin, redefining AI compute with its specialized CPU. This Vera CPU acts as the system's true brain, the ultimate conductor. It coordinates every single component, from GPU components to memory to storage. The goal is a single, harmonized AI engine where everything works together. This integrated approach isn't just about faster computations. It streamlines deployment for OPS teams, and it simplifies security auditing across complex AI pipelines. It eliminates the constant data movement bottlenecks previously holding back large models. Imagine training an AI 10 times faster, simply by making the system smarter. This intelligent system design is where the true engineering magic begins. While the previous scene highlighted Vera Rubin as the conductor, its real magic lies in engineering, extreme co-design. Most systems just bolt parts together. Vera Rubin engineers true hardware harmony. The Vera CPU and Rubin GPU units are built to seamlessly share data with ultra-low latency. This isn't just a developer concern. It directly impacts PM teams and ops teams through faster data pipeline execution and reduced system bottlenecks. Then 100% liquid cooling integration ensures optimal thermal management, preventing performance throttling. Next-gen NVLink switches provide blindingly fast communication across the entire rack. Finally, Bluefield DPU units offload data processing, enhancing both security and efficiency. This unification transforms an entire rack into one coherent, highly efficient supercomputer. After understanding Vera Rubin's incredible integrated design, let's explore the astonishing impact this orchestra truly delivers. This intelligent orchestration, it unlocks a game-changing 10x performance per watt improvement. It's not about a single component. The entire system operates as one, overcoming past bottlenecks. This slashes energy consumption significantly, reducing the environmental footprint of AI. Consequently, operational costs for AI factories see drastic reductions. This isn't just a win for engineers. Finance teams will see faster ROI, enabling broader strategic growth. Vera Rubin makes previously impossible scale-ups economically viable. Cloud providers can now offer cutting-edge AI services at unprecedented scale, and enterprises can deploy powerful AI models Once considered out of reach, many assume faster GPUs are the only answer. They miss system intelligence. This holistic approach reshapes the very foundation of AI infrastructure. The future of AI, it isn't just faster chips. It's smarter, integrated systems. NVIDIA Vera Rubin marks a pivotal shift in how we build AI. We're moving beyond component-centric thinking to holistic system design. This isn't just a developer concern, it's a strategic imperative for operations and PM professionals, ensuring exponential AI growth continues without hitting energy walls. This redefines AI deployment, making massive scale-ups incredibly feasible. Component-centric thinking will bottleneck tomorrow's complex AI workloads. None of this relies on old analogies, only cutting-edge engineering. This intelligent orchestration truly delivers on the 10x efficiency promise. This is the new blueprint for AI factories. Thank you for watching TechQuest X. If this clarified AI, like and comment below. What challenges are you facing? Subscribe, hit the bell, and find resources in the description.